Hi, Mr. Sapone here, and we're going to take a look at two density problems, two more advanced density problems that I like to give my chemistry or physics classes. So some of you may be at home struggling with these problems now. Hopefully, this will help you. And recall that density is a measure of how compact an object is. It's a measure of how tightly wound the atoms or the particles making something, composing something are. Density is going to be equal to the mass of an object divided by its volume. The volume is how much physical space it takes up. And if we kind of look at this sponge and this brick, they kind of have the same volume, but the brick is going to have a much greater mass. So the brick will have a much higher density. It's going to be physically like more heavy per the given, for the same amount of space. There's more mass per unit volume. So that sample space of it takes up or has more mass. So it's going to be a denser object. That's kind of the definition of density, how compact or like the heaviness of an object in a given space. So we have a solid sphere of gold, and it has a circumference of 31.4 centimeters and a mass of 10,100 grams. Use this information to determine the density of gold in grams per centimeters cubed. This is a slightly involved problem. And the first thing to look at, what is the problem asking us to do? It's asking us to determine the density of gold. And we know that density equals mass divided by volume. What else does the problem tell us? Well, it tells us that the sphere of gold has a circumference of 31.4 centimeters. How is that going to help us with density? That's not a mass or a volume. It also tells us that the object has a mass of 10,100 grams. 10,100 grams. So immediately I could kind of plug this number in. 10,100 grams. But I don't know what the volume is. I do not know what the volume of this sphere is. I have a solid sphere. Completely solid, gold, roughly 10 kilograms of it. Extremely expensive. So how am I going to figure out the volume of this sphere? Well, I gave you this circumference value for a reason. The volume of any sphere. The volume of a sphere is going to equal 4/3 pi r cubed. Just like a square is length times width times height, or a cube is length times width times height, the volume of a sphere, a solid sphere, is going to be 4/3 pi r cubed. Unfortunately, we don't have a radius, but we do have a circumference. And if you remember, the distance around a sphere, which is the definition of circumference, equals 2 pi r. So this is going to be a very involved problem. The first thing I'm going to have to do is use the circumference value. Solve for the radius of the sphere. Use the radius of the sphere to get the volume of the sphere. Once I get that, I can plug that in up here. So let's see what we have to do. The circumference is 31.4 centimeters. And that is equal to 2 pi r. And if we divide this side by 2 pi, and to preserve the identity, we also have to divide the other side by 2 pi. These 2 pi's are going to cancel. Radius is going to equal 31.4 over 2 pi. Radius equals 31.4 centimeters over 2 pi. And if you take 31.4 and put in your calculator, divide it by 2, divide it by pi, you're going to get an answer extremely close to 5 centimeters. So the radius of this gold sphere is going to be 5 centimeters. Now I can use this radius value. I'm going to plug it in to the formula for the volume of a sphere to figure out the actual volume that the sphere takes up. So volume equals 4/3 times pi times the radius of the sphere. The radius is 5 centimeters. So I'm going to plug that in. I'm going to put parentheses just to make it clear that I'm substituting that in. 5 cubed. Volume of a sphere is 4/3 times pi times the radius cubed. The radius is 5 centimeters. And I don't want to not forget my units there. Centimeters down there. So the first thing you're going to do per PEMDAS, parentheses, exponents, multiplication, we have to do the parentheses and then the exponent first. So 5 cubed is going to be 5 times 5 times 5. And that's going to come out to be 125 centimeters cubed. Units are combining in multiplication. You're going to simply multiply that times pi. You're going to multiply it by 4. And when all that's said and done, all you're going to do is divide it by 3. That's how we get our final answer. And our answer is going to be 523.6 centimeters cubed. So this is the volume of the sphere. This is how much physical space that solid gold sphere will take up. If this is the volume, all I got to do is plug this back into the density formula. Because density equals mass divided by volume. I didn't know the volume, so we had to kind of do a two-step process to figure out the volume. So it was a slightly involved problem. You're going to put in 523.6 centimeters cubed. And when you take 10,100 and divide it by this number, you're going to get an answer that's extremely close to 19.3 grams per centimeter cubed. And that is, in fact, the density of gold. So density is mass divided by volume. We didn't know the volume. We had to use this circumference to basically solve for the radius. And once we got the radius, we were able to plug the radius into the equation for the volume of a sphere. And once we figured out the volume, it was just a simple division problem after that. So yes, a very involved problem, but certainly well within your capabilities. And the second and final problem. On the surface of the Earth, under normal atmospheric conditions, the density of air is 1.29 kilograms per meter cubed. If a classroom is 4 meters high, 5 meters across, and 6 meters wide, what is the mass of the air in the room in kilograms? Convert that number into pounds, assuming 1 kilogram is 2.2 pounds. Okay, so again, a lot going on in this problem. Kind of the best thing we want to do is write down what we know. What does the problem tell us? Well, the problem gives us a density value. Density of air equals 1.29 kilograms per meter cubed. 1.29 kilograms per meter cubed. And they're asking us to calculate the mass of the air in the room. We know that density equals mass divided by volume. They're asking us to calculate mass. How do we solve this equation for mass? Well, if I multiply this side by volume, I would also have to multiply this side by volume. These V's are going to cancel in division. These volumes cancel. So mass is going to equal density times volume. And we already know the density. We know density is 1.29 kilograms per meter cubed. That means every meter cubed in the room has air that will have a mass of 1.29 kilograms. Now I need to multiply this number times the volume of the room, and that'll give me the mass of the air in the room in kilograms. So how do I figure out the volume of this room? Well, you might know that the volume of a cube is going to be length times width times height. Also, if you have a room that is not perfectly cubed, but it's more of a rectangular prism, it's kind of square shaped, but it is cubic in that sense, you do the same thing, length times width times height. So the room has dimensions of 4 meters high by 5 meters across and 6 meters wide. That's our length, width, and height value. So we're going to take 4 meters times 5 meters times 6 meters. And of course, this is going to be the volume of the room. Volume equals 4 meters times 5 meters times 6. 4 times 5 is 20. 20 times 6 is 120. And of course, the unit for volume is going to be meters cubed. These meters are combining. So we have our volume value now. So we're going to take this volume and we're kind of going to put it in up here to the formula where we need it, times 120 meters cubed. Now notice we have a meter cubed in the bottom, in the denominator. We have a meter cubed in the top. So the mass of the air in the room is going to be equal to 1.29 times 120. And that is going to come out to be one, going from memory, 54.8. So it's going to be 154.8 kilograms. That is the mass of the air in the room. And how do we now convert that number into pounds? Well, we have 154.8 kilograms. And every kilogram is going to be 2.2 pounds. So simply we multiply this number times 2.2. 1 kilogram is 2.2 pounds. These kilograms cancel. 154.8 is 2.2 pounds, and that comes to be roughly 341 pounds of air. So roughly in our classroom now, there will be, on a normal day, 300. All the air in the room would weigh a total of 341 pounds. It might seem like air is light, but it does add up. Air does have mass. It does have weight. And as we talk about pressure, and I show you a lot of demonstrations in pressure, this will become more abundantly clear. So 341 is our final answer. So that's two kind of complicated density problems, but I think if you sit down and try them and you watch this video, you'll be able to figure out how to solve them. This is Mr. Sapone, out.